Thank you.
All right. Great. Thank you. Thank you very much. It's a pleasure to be invited here to add my buzz to what probably is the single most overhyped topic in all of medicine today. You're going to find that a lot of what I'm going to discuss really picks up on some of the themes that you've heard about from multiple different speakers this morning, and I think you really heard emphasized in the last panel. And what I want to do in the time we have today is to talk about what big data is, talk about some of the issues in applying big data into biomedical sciences, and then give some examples. And I'll give examples, just one example in the interest of time, parochially from an application we've developed at Boston Scientific to help and aid in management of patients with congestive heart failure. And let's just begin. One of those words everyone uses without necessarily knowing what it means. You want to define big data, I figure just go to big data. And so if you type into the Google search bar, big data is, Google uses big data to predict what the rest of the sentence is. And so big data is either the new oil, the future of esports, the new oil quote, or number 5, the future of healthcare. And the question to pose really today and to consider is big data better data? Is big data just big hype? Is it truly the future of healthcare? Is big data not big enough? Do we need humongous data? Or hopefully at the end of these 15 minutes may have you agreeing that it's all of the above. What really is the definition of big data? Let's go to another big data source, Wikipedia. This is, I think, a great definition. So big data is high volume, high velocity, and or high variety information assets that require new forms of processing to enable enhanced decision making. So, volume, you've just got a lot of observations in different patients. We're talking healthcare. Velocity, that these are observations that come sequentially, often in real time. Or variety, you have multiple different measurements of multiple different parameters in an individual patient. Big data clearly is necessary if we want to do machine learning, use other AI techniques. And I think what may be the most important thing to recognize about big data is that it is an inherent byproduct of our digital lives. And so we get tons of data today at no incremental marginal cost. It's interesting, hearing the talks about bioelectronics. I kind of think, we've been doing bioelectronics in my field, implanting pacemakers, defibrillators, very good understanding of mechanism, by the way, for 50 years now. We've got computers implanted in patients, telemetering data out to the cloud. We were doing it before anyone thought to call it the cloud. And there's an opportunity to use that data to enhance our understanding of patient courses and therapies. Why do it? Well, I want to show you first of all, and I don't think this takes a lot of time, the current clinical trial model, the model by which we learn about how diseases progress and which therapies are effective, is fundamentally broken. I think also it's important to go over some of the pitfalls in big data and machine learning approaches in medicine. I don't have time to go over all of them. I could spend an hour talk, but I'll try to hit some of the major ones. But then some of the pearls and show you what we've done at Boston Scientific to use AI, augmented intelligence, and time permitting, I'll tell you why I prefer that to the other AI term, to develop a prescriptive analytic to help in the care of patients with congestive heart failure. Why do we need to do it? Well, as I said, the current clinical trial model is fundamentally broken. These are data from Monthly Labor Review showing that the cost of doing clinical trials for patients far outstrips not just the general rate of inflation, but far outpaces the overall inflation in overall biomedical R&D. So we spend more and more money to do the clinical trials to prove the therapies that people have developed in basic R&D. Well, that squeezes out any money that's available to do the basic R&D in the first place. And on the other hand, we have all of these other data sources. Today, 70% of our patients in the United States who get an implanted device, whether it's a pacemaker or implantable cardioverter defibrillator, 70% are on automatic remote monitoring. So we're getting physiologic information from all of these patients every day of their lives transmitted to us in the cloud. Well, that's the opportunity. What are some of the pitfalls? And the first pitfall that I cannot overestimate enough is the issue of adjudication of the data that we're getting from these sources. Sometimes when you go to the restaurant, you really want to know that you're getting the real chicken. And we've got an ability to do that in traditional clinical trials that we don't necessarily have with today's big data sources. I'll show you just one example. This is not to pick on Apple. I've got an iWatch. They're a great company. The tweet on the left is an actual image of an iWatch reading a patient's heart rate of 40 at a time when their heart rate on an EKG is 141. That's off by an actual order of magnitude. It's the difference between having a dangerously slow heartbeat and having a dangerously fast heartbeat. And garbage into algorithms yields garbage out. A second problem, by its very nature, the vast majority of big data analyses are inherently observational. Right? They are non-randomized. And it is much more difficult to make causal inferences from observational data than it is from a gold standard randomized clinical trial. Now, on the other hand, and the why am I an optimist, is, as Yogi Berra said, you can observe a lot just by watching. And you can make causal inferences from well-curated observational data. You just need to be careful and use some specialized techniques when you do it. And the last issue is this. Turns out that the problems we're trying to solve are complicated. One of the things that bothers me as I look at the field is the hubris of the data scientists. And I hate the term data scientist. It makes me wonder what kind of science all the rest of us have been doing all this time. But there's a hubris, and I think to come back to the panel before and the necessity of collaboration, and I think it's absolutely critical for the big data experts to be working very closely with clinicians and with clinical trialists to come to what are the difficult solutions to these complex topics in which we engage. Those are the pitfalls, but let's talk about the opportunity. This is a fantastic book. I'd recommend it to all of you. It's got nothing at all to do with medicine, by Tom Friedman, the New York Times, called Thank You for Being Late. I'm reading the book, and there's a passage that really struck me. Talked about the evolution of industrial design and industrial maintenance. So the old approach to maintenance was condition-based maintenance. If it was dirty, wash it. And then you move to preventive maintenance. You change the oil in your car every 1,000 miles, whether you need it or not. And he goes on, the new approach is predictive or prescriptive maintenance. We can now predict nearly the exact moment when a tire, engine, et cetera, needs to be changed, and we can intervene at that time. There's a great ad on TV, most of you, I hope, have seen it, for IBM Watson. And disclosure, I'm on an advisory board for Watson. It shows a repairman coming into a building in New York, and he gets stopped by the security guy, as we all do. And he says, "What are you here for?" And he says, "Well, I'm here to fix your elevator." And the guard says, "Well, there's nothing wrong with your elevator." And he says, "Yes, but there will be." Right? Because a sensor in the elevator has told him that something's going to go wrong. Well, I look at this, and I think this is exactly how we practice medicine today. You've already heard a couple of times about how suboptimal the care is today for patients with congestive heart failure. It's the single largest DRG leading to costs in hospitals in the United States today. Right? And the way we treat patients with heart failure today as cardiologists is we wait until something goes wrong with a patient. They show up in the emergency room. And then we reevaluate their heart failure care. Right? That's condition-based maintenance. Or we see in our office every 3 months whether anything's changed or not. right? And that's preventive maintenance. And what I want to show you is an algorithm we've developed that gives the opportunity to do prescriptive maintenance for patients with heart failure, trying to make medical care a lot more like elevator repairmen. It comes from a clinical trial we ran called Multisense, developed an application called HeartLogic. This was nearly 1,000 patient clinical trial, followed each of these 1,000 patients up for a year, and telemetered out literally thousands of different potential combinations of different physiologic sensors on a day-to-day basis from these patients using just standard implanted cardioverter defibrillators in these patients. Developed an algorithm and then tested it in a blinded validation test set. That's one of the critical things you need to ask for if people are trying to tell you about their great new machine learning algorithm. FDA has never before approved a device-based alert for heart failure management. We went to the FDA and said, what would we need to show you in order to get you to approve this for commercial clinical use? And they said you'd need to show that you could predict and provide early warning before at least 40% of heart failure decompensations, heart failure hospitalizations for patients with CHF. It's a very complex disease. You know, if you can do that, you're good. We blew that out of the water. We actually were able, with the algorithm, to predict 70% of unanticipated heart failure hospitalizations for folks with chronic congestive heart failure. And not only were we able to predict 70% of these episodes, we were able to predict it with a median warning time of over a month, 34 days prior to the episode, clearly giving physicians enough time to intervene if there was something remediable in that case. These are data we recently had published, presented at a scientific session as a late breaker last year, showing that in combination with a simple once annual blood test, something called BNP, we can divide patients into a group that has virtually never any episodes of heart failure decompensation leading to hospitalization, and identify a group that has one heart failure hospitalization per patient per year. A 50-fold increase in risk using this alert algorithm and using just a simple once-a-year blood test. And so, why am I an optimist about this? I want to quote Harlan Krumholtz. Harlan's a friend. Harlan is at Yale New Haven Medical Center. And Harlan has a tweet, says, you know, AI is a critical, transformative part of the history of medicine. Medicine is at its heart an information system. And the more to which we can unlock that information and provide it in an actionable form, prescriptive form to caregivers, the better we can enhance the outcome for our patients. This actually, someone referred to this the last panel. You know, the concern folks have, right, is, you know, is AI threatening to people? It's one of the two reasons I prefer to think of it as augmented intelligence rather than as artificial intelligence. Artificial intelligence sort of just seems threatening to people. The other reason I don't like the term artificial intelligence is that it presupposes that there's such a thing as natural intelligence, but that's another topic. You know, and it is these same techniques of using big data machine learning that have enabled self-driving cars. And it is the reality that we will have self-driving cars as routine on the road within the next 5 years. But that's the same thing that's going to enable us to use these same approaches to augment physicians' ability to care for our patients. And where we go next? Well, again, the pace of change is only increasing. The amount of data is only increasing. And the next time I get asked to give a talk here, I hope that the buzzword will no longer be big data, it'll be humongous data. Thank you.